Hey A&Pers, this is Dr. Jones checking in. This is A&P II Lab 2 Video 3. We're continuing with the heart model. So we said the top was the base and the bottom pointy part was the apex. And from the front, this will be your left ventricle, your right ventricle, your left atrium, and your right atrium. Now on the front of each atrium is an auricle. A-U-R-I-C-L-E, and it's a little, to me it looks like a pig ear, little pig ear flap in the front, and it inflates with each heartbeat. So left auricle, right auricle. Let's see, we also need to know, this is the pulmonary trunk. The pulmonary trunk, the pulmonary arteries are what color? Pulmonary arteries carry deoxygenated blood, so they are blue. So this is our pulmonary trunk, number 10. It is an artery. It splits to go to the lungs. So this 12 here is the left pulmonary artery. And the right pulmonary artery, we have to go around behind, is the trachea, of course. And these are the right pulmonary arteries. Let's see, I think they have numbers on them. Here we go, number 11. So these two, there we go, are the right pulmonary arteries. And the pulmonary arteries are blue because of pulmonary circuit. The colors are backwards because we're taking deoxygenated blood to the lungs and coming back with oxygenated blood. So these are the right pulmonary veins, and they have number 18 on them. 18 are the right pulmonary veins. So now we need to find the left pulmonary veins going around the front. Here we go. Left pulmonary veins, and those should have a number 19 on them somewhere. See that? There we go. So those two here are the left pulmonary veins. And the pulmonary veins, left and right, carry oxygenated blood into the left atrium. All of the oxygenated blood in the heart goes through the left side. So it's going to go through the left atrium into the left ventricle and then out of the aorta. I was trying to go in order here, so where are we? We did that? Yep, we did that. Okay. All right, aorta. Hey, we were on track. The aorta is 4 and 5 and 9. So you can see the aorta comes out of the left ventricle. As we said, all of the oxygenated blood is on the left side of the heart. In fact, that's why the left ventricle wall is so much thicker than the right ventricle wall, because the left ventricle wall is pumping oxygenated blood to the whole body. So this starts the systemic circuit, whereas the right ventricle is pumping deoxygenated blood to the lungs, which are right here, right on either side of the heart, just a few inches away. So the right ventricle wall is thinner because it does less work. It needs to pump the blood with less pressure because it crosses less distance. Okay, so the aorta is the main systemic artery, and we said systemic arteries are red. And now we need to find the two main systemic veins, which we expect to be what color? Blue. So here is one. This is the superior vena cava, number 3 here. Vena means vein. And then let's flip this up. There we go. See that blue number 20 there? Right there. That's the inferior vena cava. So the superior and inferior vena cava both carry blood into the right atrium. The right side of the heart only carries deoxygenated blood. So it receives deoxygenated blood from the systemic circuit. Superior vena cava brings the blood in from the head and the arms. The inferior vena cava, and the inferior vena cava brings in the deoxygenated blood from everything inferior to the diaphragm. So the right atrium, the right side of the heart, only carries deoxygenated blood, it enters the right atrium, goes through this valve we're about to name, into the right ventricle. Let me go back to the list. Superior vena cava, inferior vena cava, the auricles we covered. Ligamentum arteriosum. So this is our pulmonary artery, which is one of our great arteries. This is our aorta, which is our other great artery. Connecting them is the ligamentum arteriosum, right? Sounds like you need to swish and flick. So the ligamentum arteriosum, before you were born, was a ductus arteriosus. It was an open duct, a tube, but then after you were born, it closed down to become a ligament between the arteries. The reason why it's open before you were born, because before you were born, you did not get oxygen from your lungs because you were breathing amniotic fluid, and there's not oxygen delivery to the amniotic fluid. You got your oxygen from your belly button. That's right, your umbilical cord from mama's placenta, where you just sucked all of her oxygen out of her blood and took it for your own to make your own energy so that you could grow. So that's how that works. And so because the oxygen does not come from the pulmonary circuit, you have to mix the pulmonary and systemic circuits, and this is one of two places that happens. I'll show you the other in a second. The other is in the interatrial septum, which is a septum that separates the left and right atria. I like how it shows better here. Can't hold it up and point at it at the same time. So this is the interatrial septum between the thick ventricle wall, left atrium, thin ventricle wall, right atrium. Interatrial septum. So in this part of the interatrial septum, you can see the fossa ovalis. Fossa is an indentation, and ovalis means it's oval. So the fossa ovalis is the other place that before you were born, the pulmonary and systemic circuits mixed, and that connected the left and right atria. And before you were born, that was a foramen ovale. And a foramen is a hole, whereas a fossa is an indentation. So within a month or 3 after you're born, that foramen ovale should close up and become a fossa ovalis. If not, they'll watch it for a while and give it time to do it on its own, and if it doesn't close on its own, they will go in and surgically close that. So the interventricular septum is this septum that separates the left and right ventricles, but we're learning all the names of all those white lines. So it's kind of an easier question to ask over here, the interventricular septum between the left ventricle and the right ventricle. We also need the pectinate muscles, which are found in the wall of the right atrium. Also see them here in the wall of the right atrium. List, where are we on the list? Trabeculae carneae, and these are all the numbers 60 down here. To me, these look like trees, and the trabeculae carneae look like roots. So carneae means meat, just like carne gusata. The moderator band is this one right here, only this one. It's number 61. It's only in the right ventricle, and it has a different function, and we'll talk about that when we get there. Oh, sorry. Okay, turn the page. And we're going to talk about valves. So the atrioventricular valves are the valves between the atria and the ventricles. Atrioventricular, so that's why. So the right atrioventricular valve is called the tricuspid valve, R for right, tricuspid. And the cusps are the little flaps, and it has 3 little flaps. And it's the valve between the right atrium, back up, and the right ventricle. The bicuspid is the left atrioventricular valve between the left atrium and the left ventricle, also called the mitral valve. The Chordae Tendineae are these structures here. These are cords of tendon, Chordae Tendineae, and they are connected to the papillary muscles. These, to me, look like the trunks, and then the Chordae Tendineae will be like the palm fronds, or however you see them. And I do want to show you that those structures are all the same on the inside of the front. You've got the papillary muscles, the Chordae Tendineae. On the left side, you have a bicuspid valve, and on the right side, you have a tricuspid valve right there, which I can't hold and point at the same time. So the semilunar valves, the atrioventricular valves are between the atria and the ventricles. The semilunar valves are between the ventricles and the great arteries. So the aortic semilunar valve, right there, or you can just call it the aortic valve, is the valve into the aorta between the left ventricle and the aorta. And then the pulmonary valve is right here in the right ventricle at the base of the pulmonary trunk. Now, all of these valves are one-way valves, and the blood only moves in one direction. So oxygenated blood from the lungs, from the red pulmonary veins, enters the left atrium, goes through the left atrioventricular valve, the bicuspid or mitral valve, into the left ventricle, and then through the aortic valve into the aorta and out to the body. The deoxygenated blood comes back through the body, either the superior vena cava or the inferior vena cava, the little blue stripe, into the right atrium, because the right side of the heart only carries deoxygenated blue blood. And then that goes through the tricuspid valve, the right atrioventricular valve, into the right ventricle, and then through the pulmonary valve into the pulmonary trunk. And let's see how that fits together on the bottom. Just a sec. Okay, I'm back. So the pulmonary trunk, and then that splits to the left pulmonary artery to go to the left lung, and the right pulmonary arteries to go to the right lung. And then it comes from back from the lung, oxygenated, the red pulmonary veins, left and the other one is right, into the left atrium, and we start our cycle all over again. Okay, leave off right there. We will start the next video with the coronary circulation. So thanks as always for tuning in. This has been A&P II Lab 2 Video 3 of the heart. We will come back to talk more about the heart. Yeah, that was it. Okay, and the education must go on. Dr. J out.